Hi there, this is Professor Hank. In this video, we're going to continue our discussion on binary search tree theory. Specifically, we're going to focus on traversal, which is to say that we are going to talk about the order in which the nodes in a binary search tree are visited and processed. Okay, so let's go ahead and take a look at a recursive algorithm for traversing a binary search tree. Okay, so in this visit algorithm, R is going to be a parameter that's going to accept the memory address of a node or of a tree, right? So what's going to happen is if we pass null or if null is passed to the algorithm, well then we hit our base case, right? If R equals 0, quit, do nothing. Means that it's not a node. We're not going to continue making recursive calls because there's nowhere else to go, okay? But if R is not null, then we'll go ahead and we'll visit our left child, and then we'll visit our right child, okay? So let's take a look at two trees here. I've got a non-empty tree, this guy right here, and then I've got a empty tree, this guy right here. So the empty tree is for testing our base case. So if we were to call visit root, okay, so in the case of our empty tree, well, root is pointing to null. If R equals null, that's true, so we just quit right now, bam, done. Okay, but what about for our non-empty tree? Okay, well, what's going to happen is that we pass the memory address of the root node to our visit algorithm. Okay, that causes an instance of the visit function to be loaded into memory, and it's got the memory address of node A, right? So by doing that, we have visited node A, okay? Now, once that happens, what's happening is we've got the memory address of A inside of R. That's not null, so then we kick down to our recursive calls. So when we do that, we leave this first instance of the function, and a second instance is created, okay? And in this second instance, we pass the memory address of A's left child. Well, who's A's left child? B, right? So the memory address for the B node is in this second instance of visit. Now, once we're in that instance of visit, R is not null because it's got the memory address of the B node in it. So we kick down to this recursive call, and we're going to visit R left. Okay, so when we do that, an instance of the function's created one more time, right? But what's R left? Who's the B node's left child, right? And we visited B after A. Who's B node's left child? Nobody, right? So that means that B's left pointer is set to null. Okay, so when the algorithm runs, the base case is hit. This evaluates to true. So this instance of the function leaves memory, and we go back from whence we came. Okay, and when we go back to that previous instance of the function, that instance of the function was waiting right here to return from this call. So we've returned, now we can continue on to the next call, right? So what happens there? Get another instance of the function. This time we've passed the address of B's right child. Well, B doesn't have a right child, so what do we have? Null inside of R. So in this instance of the function, R is null, so we quit. So that instance of the function leaves memory, and we return back from whence we came. Right? Now remember that the function that called us was waiting to come back, or waiting to return, or waiting to return back to that function call, right? So now that's finished. So now B is going to go ahead and leave memory, okay? Returning back from whence it came. So now we're back to the original instance of the function, which was the one that has the memory address of node A in it. And that instance was waiting at the very first function call here. Now that that's done, it can move on to its next function call, right? So then it's going to pass, go ahead and create another instance of the function, okay? And what memory address are we giving it? We're giving it the memory address of A's right child, which is the memory address of the C node. Okay, so now we visited C. Okay, So once we get there, then this instance, the C instance we'll call it, is going to make this recursive call here, right? Because we didn't hit the base case. So that creates another instance of the function. What's the memory address that we've passed to it? Null, right? Why? Because C doesn't have a left child. Okay, so it hits its base case, leaves memory, returns back from whence it came. Okay, back inside the C instance, the second recursive call triggers. We try passing the memory address of C's right child to a new instance of the algorithm, but that's null because there is no right child. So that instance of the function instantly hits its base case, terminating that algorithm, causing us to return back from whence we came. So the C instance of the algorithm was waiting right here for this recursive call. That's done. So it can complete. So we return all the way back to the A instance of the algorithm, which was waiting to return with this from this recursive call. Now it's done, so it leaves memory as well. Okay. So what we had here was we visited the parent, then we visited the left child, then we visited the right child. Okay, so let's look at a more interesting example. Here we've got a tree that's quite a bit bigger. Okay, so root node is A. Okay, and here's the order in which we're going to visit the nodes. Right? Remember, we always visit parent, then the left child, then the right child recursively. Okay, so let's go ahead and begin. Root node's A, so we're going to visit A first. Right? That's where the whole thing starts. Okay, once we've done that, then we go to the left child. Okay, so then we visit B. Okay, now once we get to B, now another instance of that function has been created. So we visited B, now we're going to visit the left child. Okay, then once we've done that, we visit D's left child. Okay, then we try to visit H's left child, but it doesn't have one. Okay, so we try to visit H's right child, doesn't have one. So then we go back from whence we came, right? And then, once we're back to D, we try to visit D's right child, doesn't have one. So D and his children are taken care of, so we go back from whence we came. Okay, so once we get back to B, B's now visited his left child, so now it's time for him to try to visit his right child. Okay, so then B is going to go down to E. Okay, now once we're at E, try to visit E's left child. There isn't one, so we go back. And then we try to visit E's right child. Okay, which is I. Right? And once we're at I, we try to visit I's left child. Okay, takes us to J. Try to visit J's left child. There isn't one. Try to visit J's right child. There isn't one. Now we're done handling J, so we go back from whence we came. Okay, now we're at I. We visited I's left child. Now we attempt to visit I's right child. There isn't one, so we go right back. So we're done with I, so we go back to E. Now we're done with E, so we go back to B. Now we're done with B, so we go back to A. Okay, A's left child has been visited and taken care of. Now let's go to A's right child. Okay. Now once we get to C, first thing we're going to do is try to visit our left child, so we do that. So we get down to the F node. Once we're at the F node, we try to visit its left child, doesn't have one. Try to visit its right child, doesn't have one. Done with F, go back up to C. C is done with his left child, so now we go to his right child. Once we get to G, we try to visit its left child. And then we try to visit its right child. Now we're done with G, so we can return back up to C. Okay. Forgot to write my G in there. Okay, once we're done with C, then we go back up to A. Now that we're back up to A, everybody's child has been visited, every node has been visited. We're done, we're out. Okay, so that's the order in which the traversal is going to happen. Just a reminder, right? Think about triangle. Think about triangle. Due to recursion, we only ever have to think about 3 nodes at a time, right? Every time we visit a node, right, we're going to start with the parent, and then we're going to recursively visit its left child, and then visit its right child. Okay, so parent left, right, parent left, right, parent left, right. That has the effect, maybe you notice this, of us going all the way down the left subtree before we backtrack. Okay, all right. So now that we've talked about traversal, giving you an example of the order on a more interesting tree, let's start talking about doing some processing using traversal. Okay, so we have three different orders for performing our processing. There's pre-order, there's in-order, and there's post-order. So if we're going to perform pre-order processing, okay, what that means is that when we visit a node, we're going to process that node, and then we'll process its children. Okay, so take a look at this algorithm on the right for printing the contents of a tree. Okay, this particular algorithm is going to be performing pre-order processing. Right, I have my usual base case here. This is going to accept, this algorithm is going to accept the memory address of a tree as its argument. And again, I have my usual base case. R is going to be the memory address of some node. If that memory address is null, well, there's no node. So that ends the recursion. I don't want to display anything for, I can't display anything for a node that doesn't exist, right? Node doesn't exist if it doesn't have a memory address. Okay, but if we get past that, then what we're going to do is we're going to display the value in that node, and then we will recursively display the value in our left child node, and then we'll do our right child node. Okay, so what's this mean, right? Or how's this going to look? Okay, well, here's a list of the output that we would see on the screen, for example. Okay, we would call print root. Okay, so when we do that, the memory address of the root node is passed into R. That's not null because root's pointing to the root node here. So we get down to display, right? So we're going to display the value in that node. So we got 50. Okay, now we're going to print our left child's value, print R left. So what that does, that moves us down to the 40 node. Okay, once we get down to the 40 node, well, it's not null, there's a node there. So we get past the base case and then we display the contents of that node. Okay, then once we have done that for 40, then we're going to print its left child node's value, right? Then once we've done that, we're going to print 30's left child node, which is 20, right? Once we've done that, we attempt to print the left child node value for 20, but doesn't have one. So we hit that base case. Then we go back and try to print 20's right child node's value, and doesn't have one. So hit that base case. So we're done handling 20, we go back up to 30. Okay, so once we're up to 30, we've taken care of 30's left child, we try to take care of its right child, doesn't have one. So 30's taken care of, go back to 40. 40's left child is taken care of, so now it's time to print its right child. So we go down to 45, and once we're at 45, well, 45, we're going to display its contents, and then we're going to go to its left child. We're at 43, display its contents, then we go to its left child. Well, 43 doesn't have a left child, so we go back, and then we take care of its right child. Well, 43 doesn't have a right child, so we go back. So 43 is taken care of, so that means that we can go back up to 45. 45's left child is taken care of, let's take care of its right child. Okay, take care of its right child. Once we get there, the node itself comes first, then we take care of its left child. Well, 46 doesn't have any children at all, so we're just going to immediately go back to 45. 45's left and right child are taken care of, so then we can go back to 40. 40's children are taken care of, both 30 and 45 have been printed, and 40's been printed, so now we can go back to 50. So at that point, 50's left child has been taken care of, which was 40, so we can go to 60. Right? Going to take care of 50's right child. So once we get to 60, print the contents of 60, then try to print 60's left child. 60 doesn't have a left child, so we go back, try to print 60's right child. We're at 70 now, so take care of 70. Try to print 70's left child. Okay, we're at 65, so going to print 65. Then try to print 65's left child. Doesn't have one. Then going to try to print its right child. Doesn't have one. So we're done with 65. Go back up to 70. 70 is done with their left child, so now we're going to take care of its right child. We get to 80, print 80. Try to print 80's left child, doesn't have one. Try to print 80's right child, doesn't have one. Done with 80. Since we're done with 80, we go back to 70. Done with 70. Since we're done with 70, we go back to 60. Done with 60. Since we're done with 60, we go back to 50. Done with 50. Since we're done with 50, we're done with the entire tree. So that's an example of pre-order traversal, right? So every time we visited a node, we're still following that same traversal algorithm, right, that we talked about a few minutes ago. But every time we visit a node, we first process the node, then process the children. That's in order traversal. Okay, so now let's take a look at in order traversal. Okay, with in order traversal, what's going to happen is when we visit a node, we're first going to take care of the left child, then the node itself, then its right child. Okay, so what does that mean? What's our output going to look like? Well, let's update our algorithm over here, right, to reflect this change. Okay, just means that we're first going to print the contents of our left child, and then we will display the contents of ourselves. Okay. All right, so call our print function. It's going to happen. Start with the root node. We're at 50. First thing we do is we go to our left child, right? So once we do that, we get to 40. And once we're at 40, what's the first thing we do? Go to our left child. We're at 30. What's the first thing we're going to do? Go to our left child. We're at 20. What's the first thing we're going to do? Go to our left child. 20 doesn't have left child, so we come back. Now that 20 is taking care of their left child, they can take care of themselves. Okay, once they take care of themselves, then they can try to take care of the right child. Doesn't have one. So 20 is done, go back up to 30. Okay, 30 is taking care of their left child, so now 30 can take care of itself. Okay, now that 30 is taking care of itself, it tries to take care of its right child, doesn't have one. So now 30 is finished, and we go back up to 40. 40 is taking care of its left child, so it takes care of itself. And then it tries to take care of its right child. That gets us down to 45. Now once we're at 45, 45 tries to take care of its left child, gets us down to 43. Now that we're 43, 43 takes care of its left child, doesn't have one. Goes back up. 43 can then take care of itself, then tries to take care of its right child, doesn't have one. So now 43 is done. We go back up to 45. 45 is taking care of their left child, now 45 can take care of itself. Now that 45 is taking care of itself, takes care of its right child. Get down to 46. First thing 46 is going to do is take care of its left child, doesn't have one. Then it takes care of itself. Then it takes care of its right child, doesn't have one. 46 is done. Go back to 45. 45's children are done. Go back to 40. 40's children are done. Go back to 50. 50's left child is done. Now 50 can take care of itself. Now that 50 is taking care of itself, tries to take care of its right child. Right child 60. 60 is going to try to take care of its left child. Doesn't have one. So now it takes care of itself and then tries to take care of its right child. Get to 70. First thing 70 is going to do is take care of its left child, which takes us down to 65. 65, first thing it's going to do is try to take care of its left child. Doesn't have one. So then it takes care of itself. Okay. Once it's taken care of itself, it takes care of its right child. Doesn't have one. 65 is done. Now that 65 is done, we go back up to 70. 70 is finished taking care of its left child. Now it's going to take care of itself, and then it's going to take care of its right child. So we're down to 80. Now that we're at 80, 80 is going to try to take care of its left child. Doesn't have one. Okay, since it doesn't have one, comes back, takes care of itself. Once it's taken care of itself, tries to take care of its right child. Doesn't have one. Okay, go back to 80. 80's done. Go back to 70. 70's done. Go back to 60. 60's done. Go back to 50. 50's done. Entire contents of the tree now displayed on the screen. There's our output in order, right? So you may have noticed that we're in ascending order. If you use in order processing, then you're going to take care of the nodes in ascending order. Okay, all right. Okay, in this last form of processing, we've got post-order processing. In this example, the children come first, right? So we take care of both children, then we take care of the node. So children, then node. Okay, so the way this is going to boil down, right? If we call print and pass root to our print method, then we start off at 50 here, right? But children come first. So left child, then right child. So that would take us to 40. Children come first. Left child, then right child. Takes us to 30. Then we go to 20. Once we get to 20, we try to take care of both 20's children. Don't have none. Don't have any. So then both children are taken care of. Now we can take care of the parent. Once that's done, 20 is taken care of. Go back up to 30. So 30's left child's taken care of. Try to take care of its right child. Doesn't have any. So both children are taken care of. Now we can take care of the parent. Go back up to 40. 40's left child's taken care of. So now let's try to take care of its right child, 45. 45 tries to take care of its left child, 43. 43 tries to take care of its children. Doesn't have any. So children are taken care of. Now we can take care of the parent, 43. 43 is done. Go back to 45. 45's left child's taken care of. Now we can try to process the right child, 46. Get to 46, take care of both their children. 46 doesn't have any. So then we can take care of the parent. Okay, done with 46, go back up to 45. 45's kids are taken care of. So take care of 45, the parent. Go back up to 40. 40's kids are both taken care of. So now we can take care of the parent. Okay, that takes us back up to 50. 50's left child's taken care of. So now we're going to take care of 50's right child. Children come first. Get to 60, take care of its children first. 60's left child doesn't have any. So then we're going to take care of its right child. We're at 70. Okay, we get to 70, and we're going to take care of 70's children first. So 70 gets to 65, and then 65 is going to take care of its children first. Doesn't have any. So then 65 can take care of itself. Go back up to 70. 70's left child's taken care of. So now we're going to take care of its right child, 80. 80 goes to take care of its children. Doesn't have any. Can now take care of itself. Go back up to 70. Both 65 and 80 are taken care of. So now 70 can take care of itself. Okay, 70 is done. Go back up to 60. Both of 60's children, right, it only has one in this case, but any potential children, I guess, taken care of. So now we can take care of 60. Okay, go from 60 back up to 50. Both the 50's children are taken care of. So now we can take care of 50. Okay, so the big thing here is you're taking care of the children, and then you take care of yourself, just like a good parent would. Okay. Okay, so that's going to bring this video to a close. We talked about binary search tree theory, and specifically we talked about a traversal algorithm and covered the order in which nodes are visited. And then we talked about 3 different orders of processing. We talked about pre-order, in-order, and post-order. And depending on the order in which you visit nodes and process a node, you're going to get different results, right? And so we traced through a sample tree and showed how the numbers that we were going to display changed based off of whether or not we were doing pre-order, in-order, or post-order. Okay, so if you liked the video, please consider giving it a thumbs up, hit that like button. There's also a subscribe button there as well. If you thought the video sucked, well then you got that thumbs down button to check as well. And feel free to leave any comments at the bottom, underneath down there. Let me know what you thought. And as usual, if you're a student of mine, you have any further questions, please feel free to send me an email or stop by my office hours. Okay, thanks for watching, and we'll see you next time.